Welcome to the 9.2 Notes video. In this video, we'll be talking about inverse functions, and this is going to be related to kind of manipulating functions the way we were talking about in 9.1. So first of all, I'd like us to recall that a relation is a function if every input has only one output. Okay, so that means that every x has only one possible value of y. If I put a number into a function, I can only get one answer. And we can test this using the vertical line test. And we're going to abbreviate that with VLT, vertical line test. Okay, and what we're doing today is looking at the inverse, and inverse means the opposite. So we're looking at the opposite function. So some of the opposites that we know of already, we can talk about the opposite of addition, or the inverse of addition, which is subtraction. And we have that the opposite or inverse of multiplication is division. And what we're looking at today is how do we combine these kind of opposites in order to find the inverse of a function. And we can do that for any function. So let's go ahead and look at the inverse of a function. So we're going to define the inverse of a function as the opposite, kind of like undo. So what I like to think of is hitting Control-Z or Command-Z on the computer undoes your last step. The inverse undoes what the function does, okay? But not all functions have an inverse that is also a function. So what we're looking at specifically right now is the functions whose inverse is also a function. So if I take the inverse of a function and the inverse also passes the vertical line test, okay? And what we call that is we call that a one-to-one function. So a one-to-one function means that only one input has one output, just like a regular function, but also that every output only corresponds to one input. So before we couldn't repeat our x values, now we also cannot repeat our y values. Okay, so we add another test. So we had the vertical line test before, and now we are also going to test the horizontal line test. HLT. And that tests if any y values are repeated. So we have the test for if any x values are repeated, and now we have a test for if any y values are repeated as well. So let's go ahead and take a look at some of these relations in example 1, and we want to see, are these functions, and are they one-to-one? So the first question is, are they a function? So we need to check if the input values repeat. So we're going to look at the input values. Those are all of our x values. So our input values are 6, 5, -1, and 7. None of those repeat. And then separately, we'll look at our output values, 2, 4, 0, 3. None of those repeat, and therefore this function is one-to-one. Okay, notice I check them separately. Do my x values repeat? Do my y values repeat? Let's try another example. So for G, we have again input values and output values, x's and y's. I'm going to check, do any of my x's repeat? 3, -4, -3, 0. Oops, -3, 0. None of those repeat. And then we'll check if the y values repeat. So 9, 2, 9, 0. 9 repeats. So no, this is not one-to-one. It's not one-to-one because my y values repeated. Okay? And it doesn't matter if an x value is the same as a y value. We don't have that in this case. But if we look at example C, that's the case that we're looking at. I have an x value that's the same as a y value. But that's not the question we're asking. The question we're asking is if any x values repeat. So my x values, 1, 2, 10, and -5. None of those repeat, so it's a function. And then we test the y values. 1, 2, 10, and -5. None of those repeat, so this function is one-to-one. Even though the x and y values match, that's not what we're looking for in order to tell if this function is one-to-one. So to tell if a function is one-to-one, we first ask, do any of the x values repeat? And then we ask, do any of the y values repeat? If I can say no to both of those questions, so I don't have any repeating values, then this function, yes, is one-to-one. What if we see this graphically? So if we look at this graphically, like in example D, what we're looking at is looking at those two tests that we saw before, right? The vertical line test, which is the input values or the x's, and the horizontal line test, which is the output values or the y's. So we're checking vertical line test. Do any of my x values repeat? I can draw a vertical line through any of these points, and it only crosses through one point at a time. So we pass the vertical line test, right? If I draw a vertical line through these points, it only ever passes through one point. And then we test the horizontal line test, which is just like the vertical line test, but we're going sideways. So if I draw a horizontal line through these points, do they repeat? And right here, see how I have 3 points that the horizontal line passes through. So this fails the horizontal line test. And therefore, this is not one-to-one. So we saw examples where we were given ordered pairs, examples where we were given points on a graph. Now, this very well could have been a curve or a line on a graph, and we would do the same process, checking the vertical and horizontal line tests. And the other way we can see a relation is as a table or as a diagram. And so here we're given cities and the percent of cell phone users who use voice messages, okay? And so our inputs are the cities and our outputs are the numbers. And we want to know, do any of our cities repeat? We'll see how each of these cities is used one time. So our inputs do not repeat. And then we check, well, do any of my outputs repeat? Well, here I have 57 is used one time, 47 is used one time, but 49 is used twice. 2 inputs for the same output. So that does not pass what would be the horizontal line test. It does not pass the output question. And so no, this is not a one-to-one function. Okay, let's look at a few more examples. On example 2 on the next page, we're looking at examples that are graphic. So these are graphing examples. Okay, I'm going to do a few, and then I'm going to leave a few for you to do on your own on the try this. Okay, so in part A, because this is a visual representation, we have a graph, we're going to check the vertical and horizontal line tests. So remember, the vertical line test is asking, if I draw a vertical line through every point on this graph, does it ever cross another point on this graph? When I draw a vertical line, does it hit 2 points or just 1? And we can see that for every vertical line, it goes through only 1 point on the graph. So this passes the vertical line test. And then the second question is, does it pass the horizontal line test? So I'm going to do the same thing. Is there a horizontal line that I could draw that would pass through this graph more than one time? And this time, I can draw a horizontal line that would pass through the graph more than one time. Therefore, this does not pass the horizontal line test. As soon as it fails one of the tests, it is not one-to-one. On example B, we're going to do the same thing. So we're going to ask ourselves, does it pass the vertical line test? Well, if I draw a vertical line through any point, it will only pass through the graph one time. Therefore, this passes the vertical line test. And then our new question is, does it pass the horizontal line test? Well, if I draw a horizontal line through any point on this graph, it will only ever pass once. And so this does pass the horizontal line test. And therefore, yes, this is one-to-one. Okay, so we're asking those two questions, and that will give us the solution to whether or not it's one-to-one. Let's look at part C. So I'm going to ask those two questions again. Does it pass the vertical line test? Now this time, my graph does not pass the vertical line test because all of these points overlap vertically, right? So when I draw a vertical line, it goes through more than one point. Therefore, it does not pass the vertical line test. I don't even have to ask about the horizontal line test because it already failed one of the tests. Therefore, no, this is not a one-to-one function. Okay, so you're doing both tests, and if it passes both tests, then it is a one-to-one function. If it fails even one of the tests, then it is not one-to-one. So what you're going to do right now is pause the video, go ahead and answer D, E, F, and G, just yes or no. If these functions are one-to-one, put it into Edpuzzle, and then we'll go over the answers together. So part D, does it pass the vertical line test? Yes. Does it pass the horizontal line test? Yes. So yes, this is one-to-one. E, does it pass the vertical line test? Yes. Does it pass the horizontal line test? No. Therefore, no, this function is not one-to-one. F, does it pass the vertical line test? No. I could stop right there because already this is not one-to-one. And G, does it pass the vertical line test? No. So already we can stop right there because this is not one-to-one. All right, so what does it mean to be one-to-one? So we said the vertical line test means that every x has a unique y value. Well, the horizontal line test means that every y also has a unique x value. So there is one x value for every y value and one y value for every x value. One x for every y and one y for every x. And so we get that this is 1-to-1. Okay, so 1-to-1 means that it's extremely unique. Our values don't repeat. Okay, so let's look at how this relates to inverse functions. Well, every 1-to-1 function has an inverse that is also a function. So if a function is not 1-to-1, that means that either it is not a function or its inverse is not a function. Okay, so that's what makes 1-to-1 functions so special. To find an inverse, remember we need to think of inverse as undo. Okay, so if we look at f of x equals y, which is our basic notation for functions, we have an input of x and an output of y. So we have an ordered pair x comma y, right? If I give you the notation f of x equals y, that gives us the ordered pair x comma y. Well, the opposite of this is if I switch the input and the output. So if I have an input of y and an output of x, so if I find a function, and it's a different function now, that has an input of y and an output of x, that gives me the ordered pair y comma x. Okay, so notice the ordered pair just switched. The x and y switched places. Okay, and that would give us, if this is true for every point on our new function, so every point has x and y switched places, then we can denote it as the inverse. So this is an important notation. F inverse of x. Notice this does not mean the reciprocal. Okay, this is a special notation that means a function inverse. Okay, so let's look at some examples. On the next page, looking at example 3, we want to find the inverse of this list of ordered pairs. Well, remember when we were looking at our definition, we said the inverse has x and y switched for every ordered pair. So that means I'm just going to take this ordered pair and switch the x and y values. So this was 0, 1. In the inverse, we switch them and it's 1, 0. Okay, the next ordered pair is -2, 7. So the inverse, we switch them, is 7, -2. The next ordered pair, we have 3, -6. We switch those to -6, 3. And our last ordered pair is 4, 4. We switch those and it's 4, 4. Okay, so notice, even though those last ordered pairs are the same, because the x and y values are switched, they're also inverses of each other. And that's one of the properties that we'll see if you pay attention to inverses. The points that have the same x and y value will stay where they are. Okay, so I'd like you to do the concept check here and then answer it in Edpuzzle. Suppose that f is a 1-to-1 function and f of 1 equals 5. Find the ordered pair and the point that must belong to the inverse. So the ordered pair that we get from here, remember, f of x equals y. So x is 1 and y is 5, so we get the ordered pair 1, 5, which means the inverse, we switch the x and y values, are 5, 1. Okay, so let's look at example 4. Now for example 4, we're finding an inverse function. So not just the ordered pairs, but a whole function. Okay, so here are the steps. And I changed the formatting a little bit on your notes packet so that this line is dashed, so that it's a little bit clearer that this whole thing is one example. Okay, so f of x equals x plus 3. That's our original function. Our first step, because if we want to switch x and y, we need a y to switch. So we're going to rename this with y. So we're just going to write this as y equals x plus 3. Remember, our goal is to switch x and y, just like we did in the ordered pairs above. So in step 2, we're actually going to do that step of switching x and y. And it is this step, at step 2, where we are no longer working with f of x, but we're now working with the inverse function, okay? So that's what that line represents. We're working with a different function now. So when we switch x and y, this becomes x equals y plus 3. And now we want to rewrite our new function, right? This is now the inverse. And in order to write this as a function, we need to solve for y. So we need to isolate y, minus 3. So x minus 3 equals y. And then once we have y solved, we can write it as y equals x minus 3 and write it back into function notation. So we're just renaming it again. Instead of y, we're naming it f inverse. So f inverse of x equals x minus 3. Okay, so notice how these are opposites. In the original function, I add 3. Well, the opposite of adding 3 is to subtract 3. So f inverse, the inverse function, the undo function, is to subtract 3. Okay, now these steps will work for any function, whether it has just addition, just multiplication, or a combination of the two. So let's look at example 5. In example 5, we have both multiplication and subtraction. We're going to follow the same steps. So step 1, we're going to rename this y equals 3x minus 5. And then I'm going to put a line, because in step 2, we're not working with g of x anymore. We're working with the inverse function. And so I'm going to switch my x and y. X equals 3y minus 5. And then we need to solve for y. So plus 5, x plus 5 equals 3y. Divide by 3. X plus 5 over 3 equals y. And then I'm going to rewrite it. Y equals x plus 5 over 3. And that was step 3. And finally, step 4, to rename it as the inverse. Now, since this was g of x, we're going to name this g inverse. So it's g inverse of x equals x plus 5 over 3. If I'm typing this into a computer, that numerator is grouped together. So computer or calculator, I would type this g inverse of x equals parentheses x plus 5 divided by 3. Okay, so what I'd like you to do now is go ahead and do the try this. Remember, follow those steps, step by step, and be careful of when you're working with the original function f of x and when you're working with the inverse function. Okay, go ahead and put your answer in Edpuzzle, and then we'll solve it together. All right, so step 1, rename f of x, y equals 5x plus 2. Step 2, switch x and y, x equals 5y plus 2. Step 3, solve for x, solve for y. So minus 2, x minus 2 equals 5y. Divide by 5, x minus 2 over 5 equals y, or y equals x minus 2 over 5. And finally, step 4, rename it. This is f, so I rename it f inverse of x equals x minus 2 over 5. Now there's a couple ways you can write this. You could have written this in slope-intercept form. If you want to write it, f inverse of x equals 1/5 x minus 2/5, that's all right as well. You can write it that way. Okay? Go ahead and take a minute to look back over the notes, make sure you understand everything, and then write a summary of what you learned in the box below.